hydraulics engineer is someone who works with and designs hydraulic mechanisms and may also implement them in specialized machinery. This career falls under civil and environmental engineering and has an array of uses in the modern world that focus mainly on the flow and conveyance of fluids such as water. The concept of hydraulics is key to the functionality of a plethora of useful machinery. Put simply, it is a science of fluid moving in a confined space under pressure. A hydraulic system is used in order to output a stronger force given a weaker input force. Every hydraulic system uses some sort of fluid, typically oil or water.
Some daily routine responsibilities for a hydraulics engineer include analyzing survey reports, blueprints, and other related drawings which are all required to design structures and machines. Hydraulics engineers often use design software such as AutoCAD to create the drawings and designs to create the hydraulic machines.
The best in-state college for this career would be Duke University, offering 4 civil engineering degree programs and 5 environmental engineering degree programs. MIT takes the top spot in the nation, with its civil and environmental engineering department existing since 1865, and its 2 laboratories for infrastructure and environmental related use. The demand for this job is expected to grow a substantial 8% from 2014 to 2024 as population increases. As shown in the graph, salaries range from $55K to $100K. At least a bachelor's degree in civil engineering is required in order to apply to any hydraulics engineering job position. There are a variety of math courses you need to take throughout your college career. The ones required to obtain the bachelor's degree in civil engineering are linear algebra and differential equations, probability and statistics, and calculus 1, 2, and 3, and the mathematics of physics and engineering.
Hydraulic engineers must be licensed to be employed or sell their services publicly, considering the high responsibility they take on when designing mechanisms. Certification requires the graduation from an accredited engineering program, passing the fundamentals of engineering exam, and passing the professional engineering exam. Hydraulic engineering can be seen everywhere in our society. For example, in car brakes, where engineers have to take the small force a driver's foot can apply and magnify it to stop a 2-ton vehicle. Another example are cranes, which exploit the properties in liquids in order to lift massive loads using minimal force.
Calculating the rate of a fluid flowing into a container is a fundamental skill used by hydraulic engineers, for example, when finding how fast water dissipates during a flood or the force produced by the fluid. They use the changing volume of the fluid in the container to find the rate of fluid entering it by deriving a function of volume and time or approximating it using the average rate of change formula with specific values. These engineers must also calculate for the total volume of fluid that flows into a container, like for finding the limit capacity of a drainage reservoir. After measuring the rate at which the fluid flows, a Riemann sum can be used to estimate the volume of fluid that enters a container. If the speed function of the fluid is known, it can be integrated over bounds of 2 time values to find out how much fluid entered during that interval of time.